Moving on with our discussion on atoms, we are going to be talking about atomic numbers a bit and atomic mass now, both of which can be found on your periodic table. So that as a reference, you don't have to memorize these things, but you do have to know how to use your periodic table in order to find them. So first is identifying atoms. Atoms are identified by their number of protons. Can't stress that enough. It is protons. This might be a little confusing once we get to the fact that normally protons and electrons are the same in number, but electrons are very easily lost. Protons are pretty much set there, so we're not going to be gaining or losing protons all the time, and we're going to identify our atoms based on how many of those we have. It is just more of a standard number and more consistent number than electrons. So if you have one proton, you are considered hydrogen. Hydrogen is the H. So one proton is a hydrogen atom. Anytime we have an atom that has one proton, it is hydrogen. If it has two protons, we call that helium, or He, helium. If it has three, we call it lithium. And this is the order of the periodic table. So eventually, 4 would be beryllium, I think. 5 is boron. 6 is carbon, and so on and so forth. But it is based on the number of protons. And remember that the number of protons, those positive charges, have to be canceled out by negative charges in order for our atom to be stable, and therefore it is also going to represent the number of electrons in most cases. That is not always going to be true because we can lose electrons very easily and become ions or charged particles, but protons are going to stay pretty consistent. We are going to call this number, the number of protons, the atomic number. So the atomic number does equal the number of protons. Again, a lot of cases it's also going to equal the number of electrons. So if I say carbon has the atomic number of 6, then there are 6 protons. Carbon has 6 protons, or 6 positive charges. It needs 6 electrical or negative charges, or electrons, to cancel it out. Oxygen has 8 protons, so therefore 8 positive charges, and therefore it needs 8 electrons to cancel out those 8 protons to make a neutral charge. Iron has 26. Again, 26 protons means it's probably going to have 26 electrons to cancel them out. That's your atomic number, number of protons. You do have things called isotopes. These are variations in neutrons. So we've been talking about protons and electrons this video, but the number of protons equals the number of electrons. Neutrons, however, may vary depending on what your mass of your element is. Remember that protons have an atomic mass of 1, neutrons have an atomic mass of 1, and electrons are so small that most times we are going to negate their mass and just say, you know what, we're not going to count them when we determine mass. So over here we have different carbon atoms in our picture. They are all going to react the same chemically. They're all going to bond to other carbon atoms. They're all still the building blocks of life and do everything carbon can do. However, there are different variations of them. These different variations we refer to as isotopes. So, over here, our first carbon atom, I know this is carbon because it has 6 protons. However, this one here has lost an electron. That's still fine. It's still carbon. It has 6 protons, and carbon is defined by any element that has 6 protons. This version of carbon also has 6 neutrons. So you can see all these little bluish dots. 1, 2, 3, 4, 5, 6 of them. We have 6 neutrons. Our mass number is going to be the combination of protons and neutrons. Okay, our nuclear mass number. We have 6 protons, 6 neutrons, so we have a mass of 12 AMU. Over here is carbon-13. Carbon-13 has a mass of 13. It has 6 protons and 7 neutrons. Remember, it is still carbon because it has 6 protons. 6 plus 7 gives you that 13. Here's carbon-14. You might have heard of carbon-14 when it comes to dating. When we get into radioactive materials, carbon-14 is going to play a big role. So don't lose track of what your isotopes are. Again, 1, 2, 3, 4, 5, 6 electrons to cancel out our 6 protons. We have 8 neutrons here. 6 plus 8 gives you 14, so this one has an atomic mass of 14. Each individual version of carbon is an isotope. They are just different variations based on mass numbers. Mass can change due to the fact that our number of neutrons can vary. On your periodic table, your mass number is going to be an ugly decimal number because it is an average based on how common each isotope of that element is. So each element is going to have a mass number on there. In order to find that mass number, you're just going to sum up your protons and your neutrons. And please keep in mind that the number for the mass, this mass number is an average across all isotopes, not just a single isotope or just your common carbon-12 configuration here. So isotopes are different variations of your element.